Bathroom extractor fans, absolutely key for taking moisture and humid air from a bathroom. Because who wants steamy walls and windows? There's nothing worse, right? So this will be a complete guide on installing extractor fans, ducting to extract the air, and external and internal vents. And the best bit is that by the end of this video, you guys will be able to do this job yourself. Now the first step in the process is to install the ceiling vent, and this is a 100mm ceiling vent, and we've got 102mm hole cutter. That is going to drill a nice hole for that ceiling vent to fit up into. So you can see there's some shower pipes here. That's because we're going to have a shower right where I'm standing. So the ideal place to install our ceiling vent is right above the shower, because that allows it to pull the moisture out nice and quickly. So I like to install my vent right above the shower somewhere here, ideally in that corner, just because it's visibly better than right in the middle of the room. But what I do need to check is that there's not a joist right in that corner. If there is, we might have to have a rethink. So I'll pop up in the loft and see if there's any joists or anything in the way. Right, let's get the loft suit on. It's going to be hot up there, but you know what, I'd rather be hot than itchy, so if you can, get a loft suit on. I'll even put the hood up so I'm even more toasty. Let's get up in the loft and see if there's anything in the way where we want to put this ceiling vent. So it's quite hard to film up here. I've had to move a lot of insulation. I've had a little measure off from these shower pipes, so you can see where I've laid that hole cutter there. That's about where we're going to come through, so we should be perfectly fine to drill our hole right there, and we should miss the joists. So I've made a little mark. I've measured 150mm from this wall and 150mm from this wall, and that should be absolutely perfect. So 102mm hole saw. This is a dade. What that does is stops the plasterboard from coming all back and going in your eyes, which is not very nice. So I definitely recommend one of them. Again, I'll put a link in the description. I'll put that in my drill. You can see the dade caught all the dust and the bit of plasterboard, and we've got a hole which is nowhere near the joists, so that is perfect. The internal part of the vent that goes up into the hole, I like to just put a little bit of sealant around there. You don't have to do this. This is just a bit of belts and braces. I think if I do this, not only does it stick it, but it stops any moist, humid air potentially going past that, that duct as well. And we can just pop that up into the hole. Then you've got the cover to push up in there. You can adjust the amount that you have this open if you want to, and that just pushes up just like that. Now we're going to pop outside and install the external vent before we put any of the ducting or the fan in. Now there's a few different ventilation methods for an inline fan like this one. You could opt for tile vents, but they're a little bit more work. These are far easier. This is just an external vent with a fly mesh on it, and what that does, you can install this in a few different places. You could put it on a gable end, so you could run your ducting to the gable end of the building. You could then core through and install this on the brickwork. That's one way of doing it. The second way, and the far easier way, is to install them in a soffit. So that'll sit in the soffit just like that. So we need to get outside, get up to the soffit, much like we did here, drill a hole and install this outside. Right, let's get the little giant up there. Now luckily there's an extension that I can stand on, and I should be able to reach comfortably. So yeah, I'm up onto the extension roof and I can reach nice and easily. If you can't get up nice and easily, then you're going to have to get a tower or some form of safe access up to the soffit. Now I want my vent to sit somewhere there, so I'm just going to put a little mark there. That was my attempt at a cross, and then I'm going to drill through there with the hole saw. Same process as before. We're just going to drill that hole. There you go. We are now through up into the loft space. So the hole's drilled, but before we put the vent on, we'll pop inside and feed the ducting down into the eaves, because it's easier to do that at this stage than crawl down into the eaves and struggle to get the ducting on. So I've been up in the loft and pushed the ducting down into the eaves, so I can then reach up from the outside and grab hold of it. What you can see there is the insulation in the ducting. You can see there's an inner piece of the ducting. That inner piece there is the bit that we'll attach the vent onto. So I've just popped a cable tie over the ducting just so it can't come off, connect the ducting onto the grill, do the cable tie up and snip the end off. Now I can use 4 screws to fix the external grill or vent in place, and then you can just pop the cover on. And that is the external vent installed. So we've got the two vents in, external and internal, and now it's time for the fan itself. This is a Manrose MF100T. It's an inline fan. They're fairly expensive, but they do an incredible job versus something like the little ones that you have on the wall, for example. Whenever I've put these in bathrooms, you don't get that horrible steam up that you sometimes do even with the wall fans. We will get onto the wiring for this, but for now we just need to find a position for it in the loft. Guys, all the main components and little tools and things that you need for this job, I'll link them down below in the description so you can get them yourself. Now these are the instructions, and if you see that picture there, you can see that so far we've got the two vents in, we've got some ducting in, although we need to cut it, and our fan is going to sit somewhere in the middle like that. When we're placing this in the loft, we need 500mm either side of the fan. We can't have a very short piece of duct within that 500mm span between the fan and the vent. And another important consideration when placing the fan, if you've got vertical runs of ducting, you will need to fit a condensation trap. We've got it fairly easy. You can see the vent above the shower just there, and you can see where I've fed the ducting down through the eaves just over there. So I'm going to install the fan somewhere in between the two, which will give me 500mm on either side. It's critical that we have a nice stable base for the fan, so it's best to try and screw something like this piece of ply to the joist. Doing that will limit vibration. You can see there's an airflow direction on the fan. You need to take that into account when you place it in the loft. And now you can fix it in place. Make sure you use all 4 of the fixing points. Now it's really difficult for me to film this, but what you want to do is just cut the ducting, and we're going to join it onto the fan. You'll need to cut the wire with a pair of snips. Keep it nice and taut. You don't want loads of slack on the ducting. And then I'll use a big cable tie just to hold that in place. You can see big cable tie on there, and that is going absolutely nowhere. You can see I've tied the insulation layer on there as well, so that the insulation can't pull away or work its way away from the fan. You can see I've done the same on this side as well, and all I need to do now is connect the ducting up with the internal vent. But the sweat is absolutely running off me. That's got to be worth a sub, surely. If you're enjoying the video, please hit the subscribe button, because you don't want to miss videos like this one, and hit like, because that helps the video reach more people on YouTube. So I'm just going to cool down, and then we'll go up and connect the other end of the ducting. So I've connected it there as well. I didn't film it because it's much more of the same, but you can see the ducting goes into the fan and exits on that external vent over there. And that leaves us one more thing to do. Power it. Now at this point, if you've already got a fan isolator, this bit might be nice and easy because you might only have to relocate a cable. However, there was no fan in this bathroom before, so now I need to install an isolator, which is great because you get to see the full process and you can kind of take from it whatever bits you need. Now this is a fan isolator, and what this does is isolates the fan, and usually in modern homes you'll find these above the bathroom door on the landing. And the reason for that, as part of the building regulations, they can't be accessible by anybody standing in a shower or a bath, because then of course it could become dangerous. Now there's a transom window above this door, so we're just going to place it next to it up here on the wall. And it's worth mentioning that when you install those fans, like I just did in the loft, that they also are not reachable from anybody within the bath or shower. Now we're going to move on to the electrical section of the video. Please make sure you're competent and confident in installing basic electrical circuits like this, and if not, do give an electrician a call. Make sure that the circuit you're working on is isolated and that you've carried out safe isolation and you're confident that there's no power coming to the circuit. First, I install the metal back box for the isolation switch. I do that by drawing around the box. I then chain drill around that mark that I've made on the wall, and now I'm using a chisel on my SDS drill to remove the material. I put the grommets in my back box and fix the back box in place with a couple of screws. So I'm going to take some of the complexities out of this, and I'm going to make a little dummy so that you understand how to wire up all the different components of this little circuit without the complexities of walls and things like that in the way. This is where the power comes into the room. This is a 1mm twin and earth. That's called the loop in. This one here is the loop out. Again, a 1mm twin and earth. That goes off to the next room. Sometimes you'll only have one of these two cables if it's the last room on the circuit. Now if we move these Wago connectors out of the way, you can see see that brown live conductor coming in, that feeds the power to the room, so that gives us a permanent live. You've also got a neutral coming in here, that's the blue one, that feeds the neutral block just there. We've then got all the earths as well. You can see they're all in one block as well. And you can see here, this Wago block is all the switched lives. Now you could just copy this, but I want to explain a little bit how it works. So the power comes in, and then it travels down to the light switch. And if I flip the light switch over, ignore the earths, because there's no back boxes, we don't need to do anything with the earths. The power comes in along that brown conductor there, goes into the common. It's labelled live on this switch, but they normally have COM on them, that means common. And when you press the switch, that power can travel back up this blue conductor that's sleeved with a piece of brown sleeving. It comes back up here and it goes into this switch live block. You can see this brown conductor, that's a live, that goes off to the light, so that powers the light. The cable here that goes off to the light also has a neutral and an earth in it. Now when we press the switch, we send the power back to this switch live block, and also in there is this black conductor. Now essentially what that does is sends power to the fan along this black conductor here. That's a switched live. You can see it's got a bit of brown sleeving on there, and that travels along this piece of 4-core down to our isolator. So if I flip the isolator over, again ignore the earths, they'll be in a metal back box. You can see that black conductor there, that one, which comes out here, that's the switched live, goes into L1 on the isolator, comes out of L1 on the load side of the isolator. You can see it travels along this bit of 4-core, comes out here, there's that switched live. You can see the switched live terminal on the fan, and our fan will come on. Now also in this 4-core, you've got a grey conductor, but that's got a bit of blue sleeving on. That's on neutral. You can see the neutral terminal on the fan there. That comes down here, goes into the neutral terminal on the isolator, and at the top there, under them wires, you can see you've got a neutral there. Neutral goes back up this piece of 4-core and ends up in the neutral block. So we've got all our neutrals linked together. Now the brown live inside this piece of 4-core is linked into the live block there, and what that does is feeds a permanent live all the way along this piece of 4-core into L2 on the feed side of the isolator, out of L2 on the load side of the isolator, and up to the fan to give it a permanent live. So now if we take what we've learned on that little demonstration there and transfer that to this real life scenario, using the two, you should get a good idea how to wire all of this up. Now I'll grab a length of 4-core, jump up into the loft and wire that into the fan. We're going to take 4-core from the fan down to the isolation switch. It's a massive challenge to film up here. It's ridiculously hot, so it's a logistical challenge to get any cameras in position. I'm going to wire this into the terminals on the top of the fan here, then I'll take you through it. It's just easier than trying to do this on camera. So looking in the top of the fan, you've got switched live, that's the black conductor inside the 4-core. You've got the neutral, and there is a piece of blue sleeving just on there, but it's slid down, so that's the grey conductor, but it's indicated as a neutral with blue sleeving. You've got the live conductor, so that's the brown one, and then the earth, so the 4th conductor in that piece of cable. We don't need that, so we fold that back out the way. Now I can just put the cover back on. I think this might genuinely be the hardest video to film on the channel so far, just because up in that loft, it's a nightmare. There's nowhere to put the camera, and you can see there what I've done with the isolator. So I've put everything in Wagos. We've got our neutral loop, live loop, all the earths, and then our switched lives as well. Now using Wagos like this just makes the job a lot neater and easier to manage. We can then just pop them in a Wago box, and I can then fix that to the joist. So that's the light switch, the fan isolator, and the fan itself all installed. So now everything's wired up, and I'm going to head to the consumer unit, turn the power back on, and then I'll show you how all of this operates. Now let's turn the fan isolator on and turn the lights on, and we should get lights and a fan. There you go, and we do. I don't know if you can hear the fan running because it's quite quiet, but if we turn the lights off, we should have overrun. There you go, so you can still hear, hopefully, that the fan is running. And that can be adjusted in the top of the fan. You can take the cover off and adjust how long you want the overrun for. So this is the installation book for the fan. Watch how quick this sticks to it. So the suction there is really pretty incredible, and I don't know of a wall fan that will give anywhere near the performance that one of these Manrose inline fans will. So I hope the video's helped you. If it has, check out one of these because you're bound to like them as well, and I'll see you guys in the next one.